Well, as Crystal said, this is Brian Custer. I'm a senior consultant with 3Cloud, and we used to be Pragmatic Works, but now we're 3Cloud. And this presentation is on Delta Lake, which is a technology that was developed by the same developers of Apache Spark. It was just released in, well, the latter part of 2018, first part of 2019. So it's a relatively new technology, but it brings ACID transactions and more to your data lake. So, and we'll go into this at a 100 to 200 level. I know that they're based on the poll questions that not everyone is familiar with Delta Lake, and so we'll keep it, low key and try to present it so that everyone can take something away from the presentation. So Delta Lake, again, brings ACID transactions. The big thing that it does is it brings ACID transactions to data lakes, which is very important because data lakes can be pretty challenging to work with. And they are challenging to work with typically because of the fact that there's lots of files out there that, are semi-structured and no structure at all. And, they're notoriously messy to work with. And what I mean by that is the files, there's a lot of files out there that have been partially read or partially written to, and maybe the job failed or something like that. And so we end up with bad writes to our data lake. And so what happens is over time, we get a lot of small files and directories and bad data due to failed writes during, ETL, essentially extract, transform, and load operations. Data lakes have been notoriously hard to work with, and Delta Lake comes in really to the rescue. And what I mean by that is it essentially comes to the rescue from the standpoint of helping you to make sense of your data lake and take what used to be a really murky process, a very challenging process to work with data in a data lake, to really a pretty simple process, and one that is very easy to use, and it really helps you make sense of your data in a data lake. Delta Lake is definitely an open source storage layer. Let me move this out of the way here so I can see what I'm doing. It's an open source storage layer, and it brings ACID transactions to Apache Spark big data workloads. And I think we all know what ACID transactions are, but if we don't, I'll go over that here, and so that everyone is familiar with what I mean by ACID transactions. The key features of Delta Lake include ACID transactions, like I just said, scalable metadata handling, unified batch and streaming, which is a big deal, schema enforcement, time travel, data versioning, and upserts and deletes on your data. And finally, it's 100% compatible with Apache Spark, which makes sense because Apache Spark is the developer. The people that developed Apache Spark also developed Delta Lake. So it is indeed 100% compatible with all of Apache Spark. And you can work with Delta just like you would work with any other thing inside Apache Spark. So what are ACID transactions? Well, ACID transactions, ACID essentially stands for atomicity, consistency, isolation, and durability. And so what atomicity refers to is an all or nothing kind of situation where we either write some data to a table or we don't. So in other words, if there's an error or something that occurs, the data doesn't get written to the table. If for some other reason we decide to roll back the transaction, we can, and nothing gets written to the table. Consistency guarantees committed transactions, and what that means is that it brings consistency to your data set so that you know that the data is consistent. It hasn't been, it's not partial writes or partial transformations or anything like that. And we know that it's definitely consistent and reliable. Isolation, essentially all isolation means is that the transactions that are occurring are essentially isolated. They're independent. And then, of course, durability means that the data is never lost. So any committed data that gets written is never lost, and you never lose the data from then on. With Delta, transactions are automatic. So I don't know, some of you may be familiar with relational database systems, and you might be familiar with T-SQL syntax, where you have to go in and actually start a transaction. And then once you start a transaction, you have to physically commit the transaction. And that's, of course, if you're not using implicit transactions, with implicit transactions, the transaction takes place implicitly, meaning there's nothing that the user has to do. The transaction just happens. So that's also possible with T-SQL and SQL Server or other database systems. But with Delta, it's all automatic. So the transaction occurs without you really having to do anything about it. So you make a write to a Delta table in Databricks, for example, and you don't have to say commit transaction or anything like that. I mean, it automatically logs the write, and so you don't have to worry about doing anything like that. Of course, the transaction log is the key, as it is with any database server. And Delta stores its transaction log with the files in a special folder. And everything that gets written to a Delta table goes into the transaction log. And this then becomes the single source of truth. So your Delta data table that you've created and written to through various ETL operations or something like that becomes a single source of truth. What's the other thing that Delta is really great at is handling metadata. And of course, metadata is just data about data, right? So with Delta, this metadata is treated just like the regular data. And sometimes with big data, you can have a big data problem just with the metadata of your data. So, and it uses the full power of Apache Spark to handle that metadata. So Delta is very good and right out of the box at handling metadata. It treats metadata just like data. You can display it using a statement called essentially that's describe detail, and I'll show you that in a demo that we're going to do later. But anyway, it's just a statement, and you can essentially see all the detail of your metadata about your data. Another thing that Delta is really good about, and something that's really taken the industry by storm, is streaming and batch unification. And what I mean by that is some of you may be familiar with the old Lambda architectures, where you essentially have two architectures for bringing in your data. You have a batch system and you have a streaming system. And so you end up having to write code twice to do a batch read or a batch write, as well as doing a streaming write. So you end up having to maintain two sets of code and everything. And Delta takes that away, takes that complexity away. You don't have a situation where you have to have two sets of code to write to a Delta table from. It's an excellent streaming source and sync, as well as a batch source and sync. It overcomes limitations of streaming and batch systems. And some of those limitations are what I just described, which is essentially having to create two different systems to read in batch data versus streaming data. Another thing that Delta is known for is schema enforcement. So with schema enforcement, Schemas are enforced at write time. So in other words, when you go to write to a Delta table, if you try to write data to that table that doesn't match the schema, you will essentially get an error. And unless you have something called automatic schema update set on your Delta table, and we'll get into that a little bit later, but with automatic schema update, you can essentially let your schema drift. And all you have to do is use a statement called merge schema. It's actually an option on your Delta table, and you can set that to true, and then you can have automatic schema drift. But if you don't have that turned on, your schemas are enforced at write time. So in other words, you can't have any data that has different data types, or different columns, or different name columns, anything like that. It will actually throw an exception if you try to write that data to a Delta table. The enforcement methodology essentially is it checks for your data, and it makes sure that all the columns match, that the column names match, the column data types match, and it essentially looks at that before it tries to write any data. And if some of the columns don't match by name and by data type, then the write will fail. Let's go to time travel. So with time travel, Delta Lake is also known for time travel. And time travel, all that means is that due to the transaction log, we can go back and create older versions of the data of a Delta table very easily, just by using either a schema version number, or a version date, a timestamp. So we can go back either using a timestamp or a version number and look at past data in our Delta table and reason about that data, and maybe, I don't know, roll back or audit the data, or maybe you did a machine learning experiment on a particular version of the data, and so you want to roll back to that version to repeat that experiment. There's lots of reasons to do time travel and to go back and look at other versions of your data, and Delta makes that very easy. It's very easy to query and get your history of your data. Upserts and deletes. So with upserts and deletes, essentially you can go in and either update your table or delete your delete table rows, or merge data. And so merges are like the SQL merge into statement, except that there's additional support for deletes and extra conditions and updates, inserts, and deletes. So what that means essentially is that it's very similar to a SQL merge statement. So if you're familiar with SQL merges, you're not gonna, it's gonna be pretty simple to do a merge statement with Delta Lake. And the merge statements are actually even more powerful than SQL merges. Upserts are accomplished using merges. Updates and deletes are accomplished with a predicate. So what you do is you just like in SQL Server or a SQL-based relational database, you just go in and you say, I want to update these rows where a condition is met. And the same applies to delete. You say, I want to delete a set of rows where a condition is met. And you can do that on your data. And it's really very powerful to be able to do that, because before Delta Lake, working with the data lake and trying to go in and update some data or delete some data, it was a real chore and very difficult to do. And with Delta Lake, it's a breeze. So let's go on and talk about Delta Lake architecture. With Delta Lake architecture, essentially you have, hold on a second. I think I've got, I'm missing some slides. Bear with me here. Hold on just one second. Yeah, I've got some slides hidden here. I'm sorry about that, guys. Let me unhide these, and because I'm going too fast. Bear with me. I was doing something else, and I ended up hiding some of the slides in my slide deck. Okay. All right. Okay. Now let's go back and redo this from current slide. Let me back up and go back several slides and go to, let me see here. Let me pick up from where we started. Let's go ahead and go with a demo. So let me go with the demo here. And so I'm going to take you to the community site for Databricks. And basically, what that is Databricks has created a community site where you can go in and do essentially Databricks work on a community cluster. And the cluster is scaled down. It's not a real powerful cluster, but you can definitely go in for free and play around with the technology, get to know the technology, and you can do all this for free. So today what we're going to do is we're going to actually go into a demo, and let me pull that demo up and I'll explain what we're going to do. So with the demo, we're going to look at reading in some data from a sample table or a sample file on Databricks, and we're going to read that data into a Delta table. And it's very simple to do. The very first thing that you want to do is attach your notebook to a cluster. So I've got a cluster running right now. I started it before the presentation. And essentially, you just go in to do that. I'll just go ahead and go over this real quick. What you do is you come into the cluster page and you create a new cluster. And essentially, with Databricks Community Edition, you don't get a lot of choices here. You pretty much just get to name it. And the instance has 15 gigabytes of memory. And there's no workers. There's just the driver in the Community Edition workspace. But anyway, it's real simple to create a cluster. And once you create it, then you can come in here and create a notebook. And a notebook is just very similar to a Jupyter notebook that some people may be familiar with. And it's a great way to collaborate with your co-partners or your colleagues on doing ETL work, doing machine learning work, whatever you're doing, you can collaborate using these notebooks. And so my first demo is I'm going to show you how to create and work with a Delta Lake table. So the very first thing I'm going to do is I'm going to read in some data from the sample directory. On Databricks, there's always a sample directory called Databricks Dataset. And in this case, I'm going to read from a folder called Events under Structured Streaming. And I'm just going to read that in. I'm going to convert one of the columns that's the date column, that's a time column, into a Unix date time, and with a format of YYYMMDD. So that's all I'm going to do in this cell. So the way to execute a cell, you can either go up here and click on the Run button on the right-hand side, or you can just simply hit Shift-Enter, and the cluster will go ahead and execute your cell. And basically what I'm going to do is once I read in that data into a data frame, I'm going to display it here on screen for you. So this cluster is working on the task right now, and then here's the data frame. I'm showing the first 1,000 rows here, and essentially all it is it's just a data frame that has two columns, one with an action and another one with the date of the action. So it's a very simple data set, and this is the data set that we're going to work with throughout this demo. So the first thing that you want to do when you want to write some data to a Delta Lake table is you've got to essentially do that. Now, there's several ways you can create a delta table. Actually, there's two ways for sure, and that is, number one, you can convert, if your data is already in Parquet format, you can essentially convert your data into a delta table just simply running a convert statement. I won't get into that here, but you can do that. You can convert it straight away into a delta table if it's in Parquet format already. Delta Lake stores all its data as Parquet. So and Parquet is just a columnar data storage technology that's open source, and it essentially gives you the ability to read your data in and store it as a Parquet file that's high performance, and it's very high performance on reads, high performance on writes, and it's a great storage technology. Anyway, so now that I've got the data read into a data frame, I can go ahead and overwrite write that data to a delta table, simply running this statement here. And what I'm going to do here is I'm going to use mode overwrite just in case there is a table already named events at this location, delta/events. So I'm going to run that statement now. And essentially all that does is it's going to write the data to a delta table on disk and create essentially all the storage for the delta table, including a transaction log. So now that we've got this delta table, we can start looking at it as a delta table moving forward, and it will have all the characteristics of a delta table, including the transaction log and metadata and all of that. So once you read the delta table from disk, what we'll do next is we'll read the delta table from disk. And the way to do that is, it's real simple. You just, in Python, you just do spark.read.format delta, and you load the table wherever it's been stored. And in this case, I've stored it in delta/events. So let's go ahead and do that. I'll do Shift Enter, and we'll run the job. And essentially, all these are Spark jobs. So every time you execute a cell in a notebook, you're actually running a Spark job in the background, and the Spark job does what you tell it to do. And in this case, what I'm telling it to do is to read an events delta, essentially the events table. I'm getting it to read it into a delta table from disk. And so now I've got an events delta table that's read into from disk, and essentially I'm displaying it here. Well, it's displayed as a chart right now, but let me show you the data first. Okay, so now it's the data, and you can see the action and the date columns, just like we saw before with the standard data frame. Now we can go in and actually chart this data if we want, and we can do that by putting the date and the action. We want the action in the series grouping, and then we want to count the action in the values, and we want to store the date in the keys column. And let's see what's going on here. Why are we not getting any data in our chart? Action, we want to do a count. Okay, there we go. So let me click apply and confirm, and then we'll go back and we'll look at this data as a chart. So now you can see it as a chart, and essentially I'm just counting the close and open actions, and it looks like we got an error running command 4 for some reason. Let's see, what's on command 4? Why are we getting an error? I don't know. It looks like we have a class exception. Looks like we're trying to convert something from long to a string. I don't know what's going on there, but anyway, it doesn't matter because we've already read this data into events delta. So we have events delta setting there ready to go. So now what we're going to do is we're going to create a SQL table or a Hive Metascore table from a delta table. So essentially, we're just going to drop the table if it exists already, and we're going to call it events. And then we're going to create a table, events, using delta location. So here we go. Let's go ahead and hit enter and see what happens. So we're making the Hive catalog command, and we're doing the raw operation. So now we have a delta events table, and an events table that's based on a delta table in our database. And I'll show you that right here. You can see it right here. So this is the events table, and here's the schema for it, and here's some sample data. And so you can always use this data area to look at your Hive Metascore tables in your workspace. Anyway, getting back to the notebook, let's go ahead and pull that back up. Let's go down to where we were. So we visualized the data, and now what we're going to do is we're going to essentially count the number of rows. I'm out of sequence here is what's going on. I'm sorry for that. What happened was I read the data into a new delta table, and then I created a SQL table from the delta table, and now I'm just going to count that. So let's do that. And you'll notice that I have 100,000 rows. So now what I'm going to do is I'm going to visualize that data and aggregate it just like I would do any other data frame. So the statement essentially is we take the events delta table, that's a delta table, we do a group by action on it, and we're grouping by action and date, and then we do an aggregation, which is a count of action, and we alias that and call it action count. And then we order by date and action. So I'm going to go ahead and run that cell now. And for some reason, whenever I run the cell, it knocks me down a few cells for some reason. I don't know why it's doing that. But anyway, it's already set as a chart. And you can see here that the counts are being shown here by date. And this is all from a delta table. So you can do, like I said, you can do just about any function, Spark function, on a delta table that you can on a regular data frame. So Spark and Delta are joined at the hip, if you will. You can do anything to a delta table that you can to a standard data frame. So now what we're going to do is we're going to read in some historical events. And what that means is we're going to essentially go in and read some data from disk again. And this time we're going to take the column, the time column, and express it as a date column using the from Unix time function, and create a new data frame called historical events. So let's go ahead and run that cell. And it'll run. And so now we've got a data frame called historical events. This is not a delta table, you see, because we didn't use delta to load it. We're just bringing it in, we're inferring the schema, and we're reading it as a JSON file. And so that's all we're doing. And we're just reading it into a normal data frame. So now let's go ahead and append this data to an existing delta table. So if you remember, we have a delta table out there called events. And so what we're going to do is we're going to append the historical events we just read into a data frame. We're going to write that data frame to the delta table, and we're going to partition it by date. So let's go ahead and run that cell. And there we go. It's running now. The one thing about this community edition, I'll just say it right now, is it's a little slow. And the reason is again, we don't have any worker nodes. All we have is a driver node. So that's why it's kind of running a little slow. Normally, these things would be running really fast if I had a standard cluster with like, 2 or 3 nodes or 4 nodes. It would be running a lot faster. But anyways, this will do well, do very fine for us. So anyway, now we're going to look at the aggregate of the delta table. So we're going to use an aggregation. And again, it's the same aggregation that we ran earlier. We're just grouping by action and date and doing an aggregation, which is a count of action. And we're going to alias that column as action count, and then we're going to order it by date and action. So let's go ahead and hit the shift enter key here and run the job. I'm going to move this out of the way. And let's see, I'm going to move this like that. Get this kind of out of the way. All right. So anyway, you can see the aggregations here plotted with a real nice plot. That's one of the nice things about using Databricks notebooks is you can do pretty sophisticated plotting very easily just by clicking the plot button here. And you see here you can choose a whole bunch of different kinds of plots here, and then you can just plot your data. So it's really nice for data exploration and things like that when you're trying to explore your data and see what your data is all about. Anyway, that's the aggregation. Now we're going to count the number of rows again and see that we now have 200,000 rows because we essentially appended 100,000 rows to a delta table that already had 100,000 rows. So that gives us 200,000. And then we're going to take a look at the delta table on disk. So that's real simple to do. All you need to do is use the dbutils functionality in Databricks to essentially look at your file structure for the events table. So that's what I'm going to do. And I'll hit Shift Enter. And you'll notice here that we've got a whole bunch of files now, and they're all in Parquet format. And you'll notice that they're all named here, and then we have a part, and it's a serial part, so it goes from 0 all the way down to essentially it names them, with part -001, part -002, and that sort of thing. That's just the way that it names each file. And the file info is over here, and it's essentially saying that we're partitioning this data by date. So anyway, that's kind of how a delta table looks on disk. And then to optimize the table, we can run an optimize statement, and that's a Spark SQL statement. So you notice I'm using Spark SQL method here, spark.sql, and I'm going to optimize the events table. So let's go ahead and do that. And why I'm doing this is I have a lot of files out here, and it's going to slow my performance down if I maintain that, if I keep that. And so what we're going to do is we're going to optimize it by essentially removing a bunch of files. And you can see here that I've removed 38 files, and then I've added 5 files. So what I've done is I've compressed the number of files down, and then essentially made it the number of files. I've cut the number of files down by a considerable amount, and so consequently that's going to increase the performance of that delta table. So anyway, that's what I've done there. Now, the last thing I'd like to show, or one of the last things I'd like to show you with this demo, is how to look at the history of your table and see what you've done to the table over the course of the delta table's lifetime. So I'm going to go ahead and run this cell. And then you can see here the history. And you'll notice that the version number is over here on the left-hand side, and I'm at version number 5. And the user is stored here, the operation is stored, and the operation parameters is stored, as well as a whole bunch of other columns. The job, the notebook, the cluster ID that did the work, the read version, the isolation level, a whole bunch of other data about the operations that we did. And so it's really nice to be able to go back and look and see what you've done to your data over time. Now, again, we didn't do a whole bunch of stuff here, but if I was doing a major ETL job, you would see this table grow in size considerably, and you would see all the operations that I've done on that data. And then if I wanted to, I could come in here and select a particular version and roll back to that version. And the way I would do that is I would essentially select for that version. So I would select for version 5, let's say, and then I would select that into a data frame, and then append that data frame or overwrite my existing Delta table with that version of data. And so that's how I would roll back, so to speak, from maybe a mistake or something like that. So that's pretty much it for this. No, actually, I've got a few other things I want to show you here before I let this demo go. For show table details, essentially what you can do is you can show the details of the table. And what that does is it shows you the metadata about the table. And so I'll run this cell here. And you'll see here that the format is Delta, as we know. The name is default.event. So this is the database name of the file. And the location of the file is dbfs delta/events. And it was created at this date and time, and it was last modified at this date and time. So you also have a lot of other metadata here. You have partition columns, number of files, the size in bytes, the properties of the table, min reader version and min writer version. So it's pretty neat. You can really see a lot of information. I know this is kind of hard to see on this table because the scroll bar was getting in the way. But you can see here that the partition column is date, and the number of files that we have are 5, which shrunk way down from an original size of 38 files. And the size in bytes is 27,939. So pretty cool, really easy way to look at the detail and examine the metadata of your tables. With that, I'd like to show you one other thing, and that is how to get the format of the events table. And what this will show is, again, more metadata about the table. So I'll run this cell, and essentially it shows you the column name. So it's action and date, as we saw before, and the data types are string. And the number of partitioning, there's one partition, and it's on the date column. And there's some detailed table information here. The name is default.events. That's the name of the Hive Metastore table. And then the file location of the events Delta table is right here. And the provider is Delta, as we know. And then if I had a bunch of table properties, that would go here. I don't have any table properties, so that's why you're seeing an empty array. But anyway, that's pretty much it for this demo. I hope that you got something out of it. What I was trying to show basically is that it's very easy to go from a standard data frame to a Delta table with just a few statements, and then you can start working with Delta and using all of the features of Delta. So that was the main purpose of this demo. So let's go back to the slide deck, and what I'm going to do, and pardon me for this, but what I'm going to do is I'm going to go back and go back up to this slide here, and shoot, it's still not doing what I want it to do. Hold on just a second. What I want to do is I want to show this slide. I don't understand why it's not showing this current slide here. From current slide. Shoot. Okay, well, I tell you what I'll do. I'll just, instead of presenting it, I'll just show you the slides here. So the next thing I'd like to talk about is Delta Lake architecture. And since I'm having trouble with my PowerPoint here, I'll just show you the slide using the design surface of PowerPoint. So hopefully everyone can see this. So with Delta Lake architecture, there is a standard architecture for Delta Lake. And it's essentially all about bronze, silver, and gold. And so what that means is that we typically ingest data into our data lake, and we note that as a bronze table. And the reason we do that is because at that point, the data is really not useful for anything other than subsequent ETL actions. In other words, we can't turn this data over to our data scientists or our BI folks and expect them to be able to do anything with it because it's still in a pretty unnatured state. And so all we're doing at this point is we're just trying to ingest the data from the data lake into a known schema, and then we'll start doing our transformations and everything into silver and then into finally gold tables. So that's kind of the architecture, how the architecture of Delta Lake works. Bronze Delta tables, essentially with bronze Delta tables, again, it's just the raw ingestion of data. You go in and analyze the data for problems once you've read it in. And of course, remember now that what we're doing is we've attached a schema to the data frame. And so we read this data in using a schema. And at that point, we can enforce the schema and make sure that the write happens without errors. And we know that we have a good schema at that point. So that's really what a bronze Delta table is all about. It's just, hey, I've got a table here. It's got a schema attached to it. And we know that it matched the schema. So we're good to go for further ETL evaluations downstream. So anyway, with bronze, again, we're going to formulate a pipeline to clean the data and work on that to essentially take that bronze table to a silver table and then finally to a gold table. Silver Delta tables are essentially incrementally clean Delta tables that have undergone some ETL. We're going to go in and visualize this data typically and do some data exploration to see what else is needed. And we're going to look at it holistically and see if there's other transformations that we need to do. Maybe we need to join this table to another table or union this table to another table. The sky's the limit really with Delta. You can do just about anything you want with it. And so with silver, we're just, getting there. I mean, we're on our way to gold, but we're not quite there yet. And then finally, once we get to gold tables, these are the tables that we distribute to our end users. And our end users can be anyone from a data scientist to a BI person or an analyst at this point. Because what we could do is once we create our gold tables, we can then create Hive Metascore tables or database tables, and then BI folks can go in and actually analyze those tables just like they would any other kind of table using something like Power BI. And gold tables essentially are the result of all your ETL actions that you've done. And of course, ETL stands for extract, transform, and load. And essentially, it represents all of those actions that you've done. It's usually, a lot of times it can be pre-aggregated and for certain purposes. And it represents pristine data that machine learning people and analyst people and other people like that can look at the data and do what they need to do with it. And you can also use it for other downstream processes. For instance, the project I'm working on right now, we're actually creating gold tables that will be part of an application. So the gold tables will reside in a SQL Server database and actually become part of an application that the client uses to manage their clients' data. So anyway, that's pretty much it for the architecture. So now what I'd like to do is go into my last demo for the day, and I'll take you there real quick. Let's see, let's go to demo 2. So the first thing I'm going to have to do with this demo is I'm going to have to run essentially some cells to make sure that I have a library installed that I need. So I'm going to make sure the cluster is attached. So I want to attach my cluster that's running, and I want to run this cell here. And all this cell is doing is it's just making sure that I have this library, which is a Python library. It's called pathlib2. I'm just wanting to make sure that that library has been installed and that I can use it. Now I'm going to run some setup code, and I'm going to run this cell. And what this cell is going to do is it's going to set up some of the stuff that I need for the demo. So that's all it's doing. So just bear with me while it runs, and we'll let it run and generate all the data that I need. Sometimes it takes a little while to run. It says it's all done, so we'll assume that it's finished. Usually I get a, I'm going to run it one more time because usually I get a list of things that it's done. And this time I didn't, so I'm going to run it one more time just to make sure that it's done everything that I've asked it to do. Well, it's finished and it didn't error out, so I guess I'll assume that it's been done. Anyway, so here I'm going to set up some paths on the file system, and essentially just I'm going to set up a base path, I'm going to set up a bronze path, a silver path, and a gold path, and then a checkpoint path. And I'll go over the checkpoint path in a minute with you. And what these paths are going to, the files that we're going to store at these paths are essentially delta tables. And they're going to be delta tables at the various levels, at bronze, silver, and gold. So anyway, let me go ahead and run that cell. And you notice it happened really quickly because all I did was just set some paths. Now what we're going to do is we're going to save some raw data into a bronze table. But first what we're going to do is we're going to create a schema. So what we have to do is we have to import some SQL types using Python, and then import some functions that we're going to need from Python, or from some standard libraries anyway, from JSON and Unix timestamp. And then we're going to create a schema. So let's go ahead and run this cell. And you'll notice it didn't take very long at all because we're just assigning a schema to a variable. And then next, we're going to stream the data. We're going to actually stream some data into this bronze Databricks Delta table. And we're going to stream it from a Kafka server. And the Kafka server is located at, it's located at server1.databricks.training at port number 9092. And so this is an example of streaming data into a bronze table. So let's go ahead and run this cell and get the stream started. And we need to wait until the stream gets started before we do the other cells below. So what we're doing here is we're just waiting on the stream to initialize and start working. And what this code here represents is essentially we're loading data from this server, streaming data, and we're loading it and we're creating a column, a JSON column, and we're taking it, we're essentially extracting the data from that column using from JSON, and we're extracting it into a string with the schema attached. And so what that does is it allows us to create a delta table that has a schema and you'll notice that it's reading the data in. The stream has started. So what we've done here is we've created a delta table based on a streaming source, and the delta table is being created and appended to. You'll notice the output mode is append, and so data is being appended to that table, over and over again as it comes in from the server. So run this cell, and what we're going to do is we're going to create another high metascore SQL table based on the delta table, and essentially what we're going to do is so we're going to create this delta table, and it's essentially going to be a high metascore table, that's in our database, and I'll show you that by going to data. And we're going to go to, I think it's this database here. Yeah, it's right here, Wikipedia edits raw. So that's the table that was created, right here. And we're using the delta table behind the scenes to create this SQL table. And so, and basically we're bringing it from the bronze path. So now what we're going to do is we're going to take a look at that raw data. So let's take a look at that. And we're going to limit it to 5 records. And you'll see here that we've got a Kafka timestamp, a channel, a comment, and then a delta column. And some other columns as well. Geocoding, whether it's anonymous or not, whether it's a new page, whether it's a robot, a whole bunch of different columns here, and the URL and all that sort of thing. So anyway, that's the table that we've generated from our delta table. And then now we're going to create a silver table by selecting certain columns from the bronze table. So we're going to do a little bit of transformation here. And all that means is we're just going to select a few columns from the bronze table and bring it into a silver table. So we're going to write that to a silver table. So we're going to run that cell. And again, it's streaming data. So we've got to start a stream again. So we're using read stream, and that's all you have to do. If you do batch data, you're going to use read. If you do streaming data, you're going to use read stream. And that's the only difference between batch and streaming, really, with Delta. It's just that one statement. So that's why it really unifies streaming and batch. So anyway, we've got a checkpoint location. And the reason we have this checkpoint location is in case the streaming fails, we can restart the streaming at that checkpoint location and carry on. So that's why we have a checkpoint location. You'll notice that we're appending again. And so we're appending that data to the silver path. And so now we have a silver table, a silver delta table. So we're going to create a SQL table from that silver delta table. So let's run that cell. And we're running the command now. And so now we've got a Wikipedia edits table. So I'll show you that table. And you'll see that it's right here, Wikipedia edits. And so anyway, so that's our Wikipedia edits SQL table. And now what we're going to do is take a peek at that data by looking at the silver table, the silver SQL table, I should say. And it's updating the Delta table state right now. And then it's running the command. And so now, okay, so here we go. So this is the SQL table that we're reading from. And you'll notice that the data is displayed very nicely for us. And we could come in here and plot it if we wanted to, plot something, for instance. But right now, we're just going to look at the table itself. And now, after we've done that, we've got a silver table. It looks good. So now we're going to create a gold delta table by reading the silver table path. So let's go ahead and do that. And you'll notice that we're going to create a country code based on the geocoding column. And we're going to bring in namespace, country code, is anonymous, and we're going to group by country code. So, and then do a count. So essentially, that's what our gold data delta table is going to look like. It's going to be an aggregated table that has some data that we want to store and show. So there we go. We've created the gold data frame based on a delta table, and now we're going to display this gold delta table data frame. So let's go ahead and do that. And of course, it's a stream, so we've got to initialize another stream in order to read this, because it's all based on streaming data. So we've got to initialize that, and we're doing that right now. So it'll initialize here, and then we'll have an actual table that will be displayed as soon as it initializes. So anyway, we'll wait here. Sometimes it takes a little bit. Again, this community edition is it has a very small cluster, so we don't get a lot of performance, but it's still a good place to come and try code out and explore code and do stuff like that. I wouldn't suggest it for anybody to go and try to do any production workloads on it though. So we're still initializing the stream. Hopefully it will come up and get done here. It's going. Okay, we're good. So now we've got the display query streaming action going on, and this is the job data, essentially the dashboard of the job data. And I just got that from just basically clicking this little arrow and looking at what's going on with the job data. And it's pretty interesting. You can do a lot of performance checks. I'm not going to worry about that here because, again, this server, this cluster and workspace is not a production level workspace. So I'm not going to worry too much about performance, but I do want to show you the table, and here it is. It's got country code and then the total of the total count and for each country of Wikipedia pages. And so that's our gold table. And that would be a table that we would then do further analysis on, for instance, or send it to our data scientist and have him work with it or something like that. In this case, it's a very simple gold table. I'll grant you that, but it is a gold table and it has the data that we want in a very clean state. So anyway, that's pretty much it for this demo. What I'm going to do is I'm going to run a cell here to stop all the streams, and then I'm going to remove a directory as well to get rid of all the data. So I'm running the cell right now, and what that does is it just loops through all the active streams and it stops them. Oh, it looks like I ran into an error. For some reason, I'm getting a timeout exception on one of the streams. So I'll just go up and cancel the stream manually then. Yeah, it's right here. So I'm just going to cancel this and click yes. And then I'm going to go up and see if there's any other streams that are running. There is. So I'm going to cancel that one. Yes. And then I think that's the only streams I had. Yeah, there's just 3. So anyway, I'm canceling all those streams, and it looks like they canceled. So anyway, that's the end of this demo. So let's go back to the slide deck and real quick and wrap this up. So that was the demo. For resources, what I would recommend for people to do if you want to learn Databricks is go out to academy.databricks.com and go to their self-paced web page, and you can go out there and look at all the courses that are available, and there's a ton of them. And what they end up being is what they do is they prepare these courses as Jupyter notebooks, and then you can import those notebooks into something like Community Edition Databricks, and then do all your training on the Community Edition of Databricks. And that's what I did when I was learning. And basically, it's really nice. I think the courses are like $75 a piece. And if you're a partner, it's free. We're a partner, so all the courses are free for us. But if you're not, I think they're only $75. And then finally, there's a reference for Delta, all about Delta, and that's located at docs.delta.io. So anyway, that's pretty much it. I'm ready to take questions now. And I'll just open this up and see what kind of questions I have. Let's see. Questions. Here we are. Okay, I've got a question. Why the name change away from Pragmatic Works? Okay, so what's going on is Pragmatic Works was purchased by a company called 3Cloud. And it's happening right now as we speak. And Kevin, and it's essentially Pragmatic Works is being purchased by 3Cloud, and we'll go under the 3Cloud name soon. There's some work that we have to do to merge everything and all our operational systems, but soon we'll go by the name of 3Cloud. So that's kind of in a nutshell what we're doing there. Are there any other questions? Looks like we've got, hold on a minute. Oh gosh, yeah, we've got a lot of questions. Okay, let me expand this so I can see the questions. Wow, okay, let me see, how do I expand these? Alex Flores, that's not a question, it just says yes. Okay, I missed your mention of 3Cloud. I was getting into the meeting. Can you explain more, something about emails? How is 3Cloud related to Pragmatic Works? Okay, once again, 3Cloud has purchased Pragmatic Works. So we are going to be under the 3Cloud umbrella soon. And that's going to be taking place as we speak, pretty much. There's another question here by a guy named Van Dyke, and okay, that's again, it's just about 3Cloud and everything. So I think I've answered that fairly well. Thumbs up. I can hear you. Kevin Wolf can hear both. Todd Gain. Okay, why the name change away from Pragmatic Works? After the data is gold ready, do you feed that into the data lake for user consumption? Yes. So this question was, after the data is gold ready, do you feed that into the data lake for user consumption? And the answer to that question is definitely yes. So you can do two things here. You can go ahead and store it as a gold table, a gold delta table in your data lake, and set permissions on it and all that sort of thing, and then essentially point your users to that table, and then they can read it into their systems or their tools of choice. And data scientists can go in and do data science work. BI folks can do BI work. Analysts can do analyst work, the whole 9 yards. And then you can also do what we showed you in the demo, and that is create a SQL table that is bound to the cluster or to the workspace. And if the cluster is running, you can actually go out and query that table just like you would any other table using a connection string. And I know with Power BI, for instance, you can go in and query your data, your SQL data using Power BI. But anyway, yeah, so you definitely would put that in your data lake. Let's see, I've got another question here. Sorry, I believe that question was asked by Justin Rister. So Justin, I hope that answers your question. What is actually a data lake house? this was asked by somebody named RS. So what a data lakehouse is, essentially it's kind of a combination of a data warehouse and a data lake. And it's a concept really. And what Delta Lake does is it makes these kinds of concepts a reality because it brings in ACID transactions, it brings in all these other features, and it allows you to really transact your data like you would be transacting it in a SQL or relational data store. And so it really brings a lot of reliability and power and accuracy to your data in a data lake. And so that's really kind of what a data lakehouse refers to. It's really just kind of a concept. Let's see here. Or is the data lake feeding the raw data into Apache? What is actually a data lake? Okay, I'm sorry, bear with me. It's kind of hard to read these questions because they are not shown very well here on the screen. Justin has another question. Or is the data lake feeding the raw data into Apache? Okay, so I think maybe what they're asking here is, how do we get the bronze data? And the bronze data is really just our first initial read of data from the data lake into a Delta table. And you'll notice that we attached a schema to that data, and then we read it in. And if it didn't meet that schema, if it didn't match that schema, then it would error out and we wouldn't be able to read it in. So we would know that our data was at least matched the schema. So it allows you to feed the data into the bronze table with a schema attached. And then going forward, you can trust that data to match that schema. So that's kind of what that's all about. How do you schedule or automate the code in Databricks Notebook? Okay, so this is pretty easy to do. What you can do is you can go to your jobs and create a job. So I'm going back over to the cluster here, and unfortunately I'm not going to be able to create a job on this community edition because it doesn't allow you to create jobs. But what you would do is you would create a job and attach your notebook to that job, and then you would schedule the job to run. And so that's how you would automate your notebook. So let's see are we saying with Data Lakehouse coming in, the traditional SQL data warehouse are going away? That's a very good question. Some people maintain that. Some people believe that. Other people, including myself, don't believe that at all. I think what you're going to see is you're still going to see a data warehouse, like a SQL data warehouse, being used by people, but it's going to be in conjunction with a data lake. And because there's just so much power with being able to store so much data on a data lake and be able to just pick and choose what you're going to read into your data warehouse from there. And it's just the two together are phenomenal. I mean, they allow you to really analyze your data, all of your data, in one fell swoop. So no, I personally don't think data warehouses are going to go away anytime soon. They very well, some people may decide not to use a data warehouse and just rely on Delta Lake. And in fact, the project that I'm working on now, what we're doing is we're preparing the data into gold tables, and then we're sending those gold tables to a SQL server to be part of an application. So they're not being fed into the data warehouse, they're actually being fed into an application database. So yeah, so I mean, it's going to really depend on the person or the team or the company as to what they do there. Can you explain the features of the metadata abilities of the Delta tables? So that's essentially the features are that you can go in and essentially work with the metadata just like you would the real data. So you can go in and query the metadata. You can use the describe detail feature that I showed you to read all the metadata of the table. Now, I didn't have a lot of metadata to show you, but describe detail is definitely the way to get at that metadata. So thank you, Christine, for that question. I hope that answers your question. I'm just unclear where the data lake comes in. Okay, so where the data lake comes in is we need a place to store our data, right? So we have petabytes and petabytes of data out there, and we need a place to dump that data and store it securely, right? So a data lake is really a good spot for that kind of stuff, because we can use POSIX, ACLs, we can secure the data, and then we can start reasoning about the data and storing it in certain paths and stuff like that, and then use something like Delta Lake to make sense of the data and do ETL and all that sort of thing. So yes, a data lake is very important for storing data long term, and it's a very cost-effective way to store that amount of data long term. You compare that to a SQL data warehouse, and the costs are tremendously different. I mean, storing data in a data lake is very cheap compared to running a SQL data warehouse. So that's one of the reasons to use a data lake. So all this says is before or after ETL, so I can't really understand that question. Maybe that was part of this other question, I don't know. Here's a question. We have plans to migrate Informatica Teradata DW to ADLS Gen 2 Databricks. Okay. So how efficient would this be, and is it being done now? Yes, it is being done now. People are doing it all over the world. And it's a very efficient way to do it, actually, because what you do is you essentially just take your data from Teradata and store that data on a data lake, and then you start reading the data in using Delta Lake, and you create all your bronze, silver, and gold tables in your data lake, and then you've essentially converted all that data from your Teradata database to Databricks and Delta tables. So yeah, I mean, a lot of people are doing it and finding that it's very cost effective and very easy to do. So how efficient would this be, and is it being done now? Okay, I've already answered that question. Let's see. All right, I think that's it. Thank you very much for everyone. I think that's all the questions. I appreciate everyone attending, and I'm sorry about the hiccups with the slide deck. I'm not a PowerPoint expert, and it looks like I had a problem getting out of sequence because I had hidden some slides, and so I do apologize for that. But I hope you've learned something today. I hope you didn't waste your time at all. And I really appreciate you attending. And you can reach me at vcuster@3cloudsolutions.com for any other questions or comments, and I'll be happy to take them. So have a good day. And once again, thanks a lot for attending.
Thank you, Brian. We want to thank you so much for hosting. And like Brian said, this video will be up on Pragmatic Works YouTube channel. We will be giving out some emails about us switching over to 3Clouds YouTube channel, but the recording will be up on the Pragmatic Works YouTube channel. You guys will receive an email link tomorrow in your email box, so stay tuned for that. And if you guys have any questions, like Brian said, please feel free to reach out to him or myself. We'll be more than happy to help. I want to thank you guys again so much for giving us a nice hour of your Tuesday. I hope you guys have a good rest of your day. Thank you, Brian.
Thank you.